Alright, champions, last episode on this one, and then I promise we'll never speak of this again. For some reason I said this thing was built in the US. It wasn't built in the US, it was built in the UK. Everyone clarified in comments multiple times. Thank you, champions. So let's give this thing a test. I've talked to the customer. I advised him that it's a good idea to change these to 6v6s for many reasons. One of them being less heater current draw on the transformer, which is a plus. We can actually bias them to 95-ish%, but 100% before it starts to sag the B plus so much and overload the transformer that you can't even reach that. The other reason, pretty important as well, is the output power will be a bit lower, so we'll have more of a chance of that Alnico Blue surviving in the long term, because that's a 15 watt speaker, and if this thing's actually putting out 18-20 watts, it's borderline not safe for that speaker if you push the amp pretty far. And to keep the voltages under control, we'll switch over to a 5Y3 as the original sort of 5V3 circuit. Lots of numbers: 5V3, 5Y3. Misspeaking is a hell of a thing in videos. Later on I'll be editing, I'll realise I said something dumb. Sometimes I'll put text there, other times I'll just assume you know what I'm talking about because you're a bunch of bloody legends. So you fill in the gaps when I don't, champions. So we'll do some initial testing, just figure out where everything's sitting, check the bias level, take notes, check the ripple, all of that. Basically give it a full service with these valves, take all the measurements with these. Then we're going to switch over to 6v6s, redo all of that, and that way we've got two sets of data before and after. Insanity, sanity, So I'm already predicting a few things will be an issue. So cutting the signal and throwing it through a big snake out to another box is not a great idea, but it's the architecture of this amp that we've got to operate under now, because it's the way it was built. Unplugging this just bypasses it. So, that's... If you can live without the reverb, you just unplug that and it's just lead dress, not ideal. You got wires running right next to the heater and everything, but at least you're not taking it on this big snake out to the reverb. So the other thing is an inherent ground loop in the reverb box, because you've got a ground connected here shielding these, going off to an uninsulated switchcraft socket on this box, and you've also got a ground here, that the green one, the brown wire going to ground here, and that's the ground for the power supply for that box, which goes off on its little handmade loom there, which is like the power supply for the heaters and the high tension, and it's also got a ground wire in there. So you've got a big ground loop essentially. So we could probably break one of them. I don't want the return currents coming on the signal line, obviously. So what I think we might do is, if it's connected at both ends, we'll break the ground in the reverb box on the end of that. And that way this will be grounded here, and your main ground will be the power supply. We'll see if that improves things. I reckon there's going to be quite a bit of hum. But let's not count our chickens before they hatch. Man, we've got cows coming home in the other episode. We've got chickens. It's a old McDonald had a amp. The other issue I think we'll have is with the variable voltage in relation to the tremolo. So as mentioned in the previous episode, I think it was the previous episode, I'm forgetting which one's which, the high tension for the tremolo driver is derived directly from the rectifier pin prior to the VVR circuit. So that sits at the same voltage regardless of what the VVR is set at. So you're going to end up with like full swing, because this is what they call a bias wiggle tremolo, or various other words for it. But essentially, it's changing the bias on the output valves to derive the tremolo effect. If this is sitting with the same swing regardless of what the HT is, we're probably going to get some weird sort of behavior going into cutoff, maybe popping, clicking, just like real gatey kind of behavior. Probably some distortion riding on the peaks of the tremolo sort of modulation waveform. I don't think it's going to sound great. So what we can do is we can either move this to here, or we can move it to the screen node, which is conveniently right here. It doesn't matter that it's on the tube pin, the valve pin. They both are connected. There's not actual screen grid resistors per valve on this model. So that comes to here, the screen node, and we could run it on the screen node, which is also varied by the VVR, because this adjusts everything in the amp except
the Tremolo, which seems a little bit naff to me. I think there will be performance issues, but let's have a listen to everything, and we'll at least we'll have a before and after comparison then of you know, what we've done and what it's achieved, if anything. Now I'm getting comments that I'm whinging. All of this is whinging, like fault finding is just inherently whingy. I don't know what to tell you. If you don't like it, fuck off. Go to another channel. Go to a channel where you get told comforting lies. I don't really care. You mean nothing to me. So far, I feel like I've been pretty objective and charitable to this end, to be honest, at least compared to my usual rants. I'm trying to move a little bit away from that because it's easy to go down a little rabbit hole there, and it's not good for my or your mental health. So let's just deal with the facts in our face and leave our opinion out of it a little bit more than I have in the past, you know. People will still whinge because people are fuckwits, but, you know, you do the best you can. The other thing I wanted to clarify was the the figure that I arbitrarily put on these amps of $8,000. I did some research online, found them sold listings on Reverb for like pushing $8,000. When you combine the conversion rates, the import charges, and add GST to them, which is another 10%. Yeah, we're about the $8,000 mark. Having said that, getting a definitive cost for a new build out of these people is something that would only occur if you actually paid a deposit, or, you know, like initiated a build. And I think suffice to say I'm not going to do that. But there may be scarcity at the moment too. I'd imagine because these are hand built, there's probably a pretty slow production of them, and the waiting list would be rather long. So of course that inflates the second hand market. So I think some of that comes into it as well. And, you know, 8K was a nice round figure. And, you know, clickbait. It is what it is. God blimey, champions. It's go time. Well, no flames, so that's good. Better than it was. That's right, champions. We've got everything on the table. Got all our cards on the table. Everything's plugged in to everything. Box City. We've got our little problem child transformer back there in the corner thinking about what it's done. We got the 6L6s, which is not a good idea, but I at least want to have some measurements to back up my argument now. So let's get to it. We'll see where these are going to sit with the new transformer. I already know, because it's just common sense, but let's see where they are, and then we'll put some 6v6s in and compare. Alrighty, so it's stabilised. We're drawing about 108 watts from the wall, which is quite a bit. However, the 6L6s are only coming up to about 60%, and that's at about 108 watts from the wall. This is a total load, like 128 something watt transformer once you add up all the currents and voltages. So we're not far from its limit, and I don't want to push things any further than they already are. So I've talked to the customer, and he's happy to go ahead with reverting back to 6v6s and a 5y3 as per a original 5v3. So that will make things a lot cooler and happier, yet the valves will still be biased at around 95%, which is about what we want for a cathode biased amp. So with the VVR fully up, variable voltage, about 415 volts. As we dial that in, brings it down, say at 12 o'clock, it's about 220-ish. And all the way down, you're probably in complete cutoff there. It's about 63 volts. So really, probably should have end stopped a little bit higher than that. So it stops at, say, I don't know, 150 volts or something, maybe, yeah. Maybe 200 volts maximum scale, because it's going to be pretty useless under about 150 volts anyway. It's just everything's going to be performing way out of spec and acting weird. So for the meantime, we'll put it up full. The customer actually said he doesn't use the VVR much at all, if ever. He just got it because it was an option, and he thought he might want it later if he hadn't at least tried it. But maybe the reason he doesn't use it is because it sucks. So with the VVR turned all the way up, we've got about 15 volts ripple there on the B+. Alright, so she's up and running, drawing 110 watts from the wall. We've got the VVR all the way up. Plate voltage 417, 418. So what I'll do is I'll measure the voltage drop across the primary. Don't do this at home. Don't even look at your amp. Don't touch it. Liability, 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 blah, 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 blah. Alright, so initial startup. 320, 287 ohms on each side of the primary. We were seeing a 16.7 volt drop, 15 volt drop. When you divide that by the DC resistance of each side, you get the current, the plate current for that side. They both worked out to 52 milliamps. You don't necessarily want to see the same voltage drop, because when you have different resistances, we are drawing the same amount of current, but that corresponds to a different voltage drop. So don't panic if you see a pretty big imbalance there, if the resistances are out of balance as well. So 52 milliamps, so that's pulling about, when we go with a plate to cathode voltage of 370 volts, that's about 19.3 watts. 64% dissipation in a cathode biased amp. You're generally aiming for around 100%. So to get that up to the 100% that we want to see for a cathode biased amp, we'd need to increase that by, that's like 2/3 of what we want. So we'd need another like 10 watts per side. So 20 watts in total. That would overrate the power transformer, because we're already sitting at 110 watts from the wall. So that backs up my my claim that we should put 6V6s in here. So anyway, I've talked to the customer. We're putting 6V6s in there. Let's have a listen with these 6L6s, and then we'll pop them in and take some more measurements. All right, so first off, we'll have a look at the noise floor. Increasing somewhat when you turn up the reverb, but not as bad as I would have expected given the ground loop. So maybe they have cut one of those grounds. I have to dig deeper. I've got the lid on it at the moment, so I have to take that off and have a look. Let's turn that off for a sec, just to isolate things. No hum when it's turned down, good. Turn the trem on. Ooh, got a healthy thump there. And that adjusts the speed. That is kind of handy, to be able to change that on the fly. But you kind of can't have it all. You're running things really long distances, you're sharing cables with stuff, there's going to be crosstalk, there's going to be weirdness. Scratchiness on the volume, I have to check that for DC as well. That could be board leakage. I doubt it would be a cap going, but you never know. That's on both of them. Let's try the VVR. Yeah. So as I suspected, as you turn the VVR down, things are starting to act weird on the trem. So yeah, we'll see how changing that node will affect that. But yeah, you know what the base level noise there is now at least. Alright, so let's just try the bright channel to start. Very woofy, a lot of bottom end. So I reckon he's gone with the stock 5E3 values there instead of tailoring it to guitar, which this amp's marketed towards, so why wouldn't you change the voicing? So quite a bit of ghosting there, as you can hear. There's sort of like a subharmonic riding on the actual note.
sort of like a zwing, zwing, zwing every time we pluck. And there's a sort of rumble happening under it as well, which could be microphonics in the 6L6s. Yeah, maybe not. Alright, let's try the normal channel now. Bit loose, a little bit uncontrolled, so are 5E3s, but a little bit flabby. There's some weird subharmonic stuff going on a bit, and the top end's a bit fizzy. Now, a lot of the time, these amps, the 5E3s included in their stock form, can sound okay for single note stuff, but when you start playing chords or weird intervals, the ugliness sort of can come out a bit. A lot of that's to do with bottom end control, so bringing the tone up has improved that a lot. When you're below 12 o'clock, things get pretty flabby and messy. The tone control is a sort of two-way thing. That's like a treble cut, and then that's like a bass cut. That's the way the circuit works. So when you're cutting the bass, naturally the tone control's cutting the bass there. There's less low-end content to flub out and blocking distortion than the upcoming stages. There's also no grid stopper on the PI of this, which is a modification I like to do, which reduces the blocking distortion significantly. I want to check out the reverb first. All in all, that's not a bad reverb tone. This is just my test tank. This is not the one out of the actual cabinet, and that's the tube amp Doctor. I've found them to be pretty dark for what they are. So this circuit, along with that, is not a bad mix, but that is a particularly dark reverb tank, so don't take that into account on this, because the one that's in there is probably brighter. A slight increase in hum as you turn the reverb up, but that can be pretty common. I've got the pickup end of the tank furthest away from the transformer. And obviously I've got the soldering station that it's up against turned off. We'll turn the reverb off, just have a listen to the trem. Trem can sort of modulate the distortion of the output stage, which in my opinion doesn't sound very pleasant. You kind of want to modulate the already clipped sound, and that's not the way it's working in this circuit. But anyway, let's try it with the variable voltage and see what that does. As expected, things get really out of control, particularly when you go past 12 o'clock on the VVR. From 12 o'clock up, it's usable.
kind of weird distortion. No, it's not a real pleasant thing. This is with the volume at 12. I had my guitar volume at like 6, 7. That's usually where I play with the Deluxe. Obviously this thing's meant to be played a bit differently. Anyway, let's now we know what it sounds like. We know the measurements. Let's put some 6v6s in there. We'll change that node of the tremolo to the screen node, and we'll see how that treats us. Alright, champions, we've got the Tube Amp Doctor 6v6 GT STR red basses in there, which is my preferred 6v6 at the moment. And JJ's 5Y3, that's an older JJ's. It's been in my stock since about 2019 before the glass issues, but it's my last one, so that kind of sucks. We'll have to source some more of them. We moved the node for the tremolo to the screen grid node, and straight away there's no trem thumping, or greatly reduced anyway, because we're not taking those output valves completely in and out of cutoff because they're biased so cold. So we'll let that stabilise for about an hour. We'll let those valves burn in. All the manufacturers say they all burn in the valves, but I do see them change slightly with the dissipation after they've been run for about an hour or two. So with the new 5x3, that's brought the plate to cathode voltage down to 336 volts. We've got 12.5 watts and 12 watts on either side. 104% and 100%, so we're pretty much bang on where we want to be, just like without adjusting the cathode resistor at all. And the power consumption from the walls dropped down to about 86, 87 watts. So all in all, things are a lot more comfortable. Alright, it's test time, legends. So I quote all this stuff on my invoices, partially for my own reference, but also if you move interstate or something and you've got, get the amp serviced or some problem pops up, you can show your local tech, at least this is what I measured at this point, you can contact me, blah blah blah. It's just good to have a record of all this stuff and also show that I actually did something when I serviced it. Well, the videos help with that too. So I've got my newly repaired 2236 here. Dad restored the vertical, I don't know what you'd call them, drive resistors, whatever. It was causing the beam to be way off kilter. So now she's purring again. This is a beauty one because it's got a little multimeter built in, and Panny Boy loves focusing on it. So that top row there with the readout, beautiful little vacuum fluorescent thing. I love those things. It takes me back to the days of VCRs. That shows us at the moment we've got that set for volts RMS. It's a true RMS voltmeter. So we take that to the edge of breakup. You just see the top and bottom leveling out there, and we're at 9.6 volts AC, and that corresponds to about 12 watts, something like that, into 8 ohms. If you push it hard, you can see the bias starts to shift and you start to get some crossover distortion there, which is pretty typical behavior of a cathode biased output stage. And if we set the frequency input to 5 kilohertz or something and set the sync to line, which synchronizes the trace to the actual 50 hertz mains rather than the signal itself, I can show you what manifests itself as ghost notes. So you see there that ripple riding on top of the waveform as we push into distortion. That is the 50, that's 100 hertz because it's rectified, but that mixes with the original signal and gives harmonics, which are a subharmonic of the fundamental of the note. So that's where ghost notes come from. And as you have less and less rippling in the power supply, and as you have less and less filtering in the power supply, more and more of that ripple finds its way through and manifests itself as ghost noting, usually up the neck a bit as you're playing under pretty heavy output. Now, ghost noting is not necessarily a bad thing. If you go too hard with the filtering, you change the dynamics and the touch sensitivity of the amp. So it's sort of a balance, and horses for courses. Big metal amps and stuff will have a shit ton of filtering, whereas more vintage style amps will be a little bit looser, a little bit more loosey-goosey in the hips, and have a bit more of a spongy feel with less filtering. So also with valve rectification, as I think I mentioned in the first episode and other videos, that the rectify valves do have a limit as to how much capacitance you can throw directly at them. So yeah, that's mentioned in the data sheets of each valve type. So I think the Alnico Blue will be safe with those 6v6s now. So that's another reason to do all of this. Let's get it back in the cab. I'm not going to test it with the bench speaker. Let's get it back in the cabinet and test it in its natural environment with the Alnico Blue and have a listen. Alrighty, all the guts are back in the cabinet. Giving it another test. I just did a few things like flying stuff up in midair. I might shorten that wire a little bit. Just lifting the grids away from the heater wires wherever I could, just to reduce the hum levels a little bit further. We popped the 12AT7 in there. The reverb's sounding a lot fuller, so I'll pop the back on, secure all these cables, and do some sound tests. So to get around reattaching in another ground wire there, which is kind of annoying for servicing, I've just put some extra copper tape on there, and it's just sort of created little tabs where the foam is compressing into the chassis, so that should offer some pretty good grounding on the ends there. And just did a little dob of solder there just to make sure that everything's got continuity. And I've popped some shields on the valves. It's probably hard to see the reverb ones back there, but you can just make out. Just so when you're shoving cables in and out and stuff, you don't accidentally catch the nipple of it and break its vacuum. It's not the kind of nipple pinch that you're after. Alright, champions, so I think that's a vast improvement. All the trem thumping's gone. It breaks up more gracefully because it's not biased so cold. It's not using as much power. It's not overheating the transformer. The transformer's been upgraded, so it's a more hefty model to deal with the extra heater current. All the stuff we mentioned. Thanks for your patience on this one. It was a little bit of a lengthy video. I've been trying to chop it up into bite-sized pieces to make it more manageable. The pricing was a little bit probably overestimated. We're looking at the second-hand market over here because there's just none available, so there's probably a scarcity thing there. Point being, it's a pretty expensive boutique style amplifier, and that's what it's marketed as. But now it sounds fantastic, and if you've got one of these and you're worrying, and I've seen a few comments in the videos that I've got one and now I'm concerned, or I've got one and you're a jerk off who doesn't know what you're talking about, but it's just like your opinion, man, like the dude says. If you've got one, just take it to a tech, get some 6v6s put into it, a 5y3 rectifier, move that tremolo node to the screen node, and you're happy days, mate. Don't stress, just get it sorted, and then it'll be a fantastic sounding, long lasting amplifier. And I think that sounded really good. I don't know, maybe I'm just in a good mood today, but I thought that sounded fantastic. It sounded tweedy. It did the same sort of, reacted the same way as when you roll your volume back on the guitar and you get the nice glassy high end, which is what my 5E3 does as well. It felt pretty similar to playing my 5E3. So I think that's a success, and all in all, it has its shortcomings, but it's going to be a very nice sounding, long lasting amplifier now. So thanks for sticking with me, and I'll see you on the next one, you legends. We've got another little tweedly-do for us to have a look at and rip into, and hopefully it comes up with the goods, because it's another expensive one. So I'll see you on that one. Don't forget to like and subscribe if you know what's good for you. If you know what I mean. If you know what I'm saying. Because I'm a like-based life form and I need likes to survive. I've got a deficient like gland. Fuck. Oh, what am I talking about?